Section 9.2, analyzing rational functions. Okay, so here we have a rational function, x squared minus 5x plus 6 over x minus 3, but we have a non-permissible value. There's a value of x, namely 3, that would make the bottom be 0. And our definition of a polynomial function said we can't have 0 on the bottom. But what I want to know is what happens when we get really, really close to that non-permissible. So I set up a table of values here, and I'm going to teach you how to do a table of values with Desmos. So what I'm going to do is I'm going to put 2.9 in for each value of x and see, and then closer and closer up to 3 what happens. And so I set up a table of values. So on Desmos, I went table, and then I actually typed in the function here. So when I put in 2.9, I get 0.9. When I get 2.99, I get closer. 2.999, closer again. What other values did they want us to do? 3. Well, what happens when I put the value 3 in? Oh, undefined. Well, what if I get just a little bit more than 3? Well, close to 1. So it seems like I'm getting pretty close to 1. And then when I get further away, I get further away from 1. Okay, so it looks like I'm getting really close to 1. Okay, so those are the values we're going to put here. So we saw that it was getting close to 1. So this was like 1.1, 1.01, 0.01, undefined. This is 0.99, 0.99, and this is 0.9, I believe. Okay, so it seems like we're getting really close to 3, but it isn't defined right at that point. So it's not like it's an asymptote, okay? It's not approaching something. Or maybe it could be an asymptote. Actually, we don't know that yet. It might be but it seems to be approaching the value of 1, right? So when x gets close to 3, y gets really close to 1. So from this side, it got really close. And then after 3, it's just a little bit more than 3. So it got really close to 3, or 1, rather, right there. Is there a way we could simplify this function? Well, in fact, there is, and we could simplify it to be y equals, if we factor the top, we would get x minus 3, x minus 2, and the bottom was x minus 3. So if we canceled out the common factor, this would simplify and look just like x minus 2. Okay? So it seems like it's just like x minus 2. But I want to show you the difference between those two functions. We'll see which one I had it on. I had it on this one. Okay, so here's the function, the original function, and here's the function y equals x minus 2. So they look almost exactly the same. But I want to show you about what happens exactly at the value 3. So right here, so we're getting close to 1, close to 1, close, go close. Oh, undefined. And now Desmos won't hold that for me, but you can see how all of a sudden there is this circle because this graph is not defined when x equals 3. This function is not defined. Sure, it looks like that green function, but this green function is defined everywhere. At the value 3, that's defined. Okay, so there is that slight difference between them. So when you do reduce, you lose some information because this function does not exist. At 3, this one does. Okay, so what we need to do is we need to graph this function, and it said using technology. So we see it's a straight line. The only thing we're going to have to add is that there's a circle right there. It is discontinuous there. So it went from -2 to 2 to kind of give me my slope. Okay, at -2 and 2. So it looks like we just keep rising. But at 3 and 1, we have a discontinuous. We have an open circle. So it is a line. It looks just like the line x minus 2, so y-intercept of -2, a slope of 1, only we have this discontinuous. So make it really clear on yours that at 3 and 1, we have discontinuous there. Okay. Now we're going to compare the behavior of their functions that they're non-permissible. So these functions both have the same non-permissible. They have the same denominator. So 4 minus 2x cannot be 0. 4 cannot be 2x. In other words, x cannot be 2. Okay, they have the same non-permissible. Now this function here, it's undefined. And this function here, it looks like we have an asymptote at 2. So why the difference? Why did that come out differently? It has to do with when we factor these. So this first one, if I were to factor this one, I would get y equals x times x minus 2. If I factored out a -2 here, I would also get x minus 2. So I kind of did two steps in one here. When I took out a -2, this became positive and that became negative when I factored out my -2. So that's why I got my x minus 2. Okay. So notice that these two shared a common factor. They both had that x minus 2, and it resulted in a discontinuity. Discontinuity. There we go. This one here, if we factor the top, we would get x times x plus 2. And when we factor the bottom, we get -2 x minus 2. They do not share a factor, and here we have an asymptote. Okay. I do want you to notice this 0 here. X equals 0 corresponds to a point right there. X equals 0 corresponds to some point right here. And here we would have x is -2, and that's there as well. So factors are telling us something, giving us some information. In fact, to find any x-intercepts, points of discontinuity, and vertical asymptotes, analyze the numerator and denominator. If a factor is only in the numerator, so let's go back to our example. What was only in the numerator? Here it was just x. X equals 0. Only in the numerator here we had 0 and -2. So if it's only in the numerator, it corresponds to an x-intercept. Okay? If it's only in the denominator, it's found only in the denominator. Whoops. So our example with only in the denominator was this guy right here. It's only in the denominator. At 2, we had a asymptote. And finally, if it's in both the numerator and the denominator, then we have a point of discontinuity. Okay, and we're going to use that idea to solve problems like this. We need to match the equation of each function with the most appropriate graph, give reasons for each choice. Okay, So first of all, I'm going to factor here. This is the same as x times x plus 2. And then I have x minus 2, x plus 2. That is a difference of squares. Okay, so for this function right here, I'm looking for something that's a 0 at x, because it's only in the top. So something where it goes through 0. So this one or this one. I'm looking at one of these two graphs. Okay, if it's found in both the top and the bottom, it's found in both, then it is a point of discontinuity. So here we have x plus 2 in both. So at x equals negative 2, we should have a point of discontinuity. Right here, point of discontinuity. Here we have an asymptote. Here we have a 0. So it's neither of those. And then just to check if it's found only in the bottom at 2, then it should be a asymptote, which it is. So this is clearly going to be this graph right here. Okay? Now let's look at the next one. We have 2x plus 4 over x squared plus 1. The only thing I could factor out here is a 2. Then I would have x plus 2 over x squared plus 1. Okay, if it's found only in the top, it is a 0. So we have a 0 at negative 2. If it's only on the bottom, it would be an asymptote. Well, x squared plus 1 equals 0. When I solve that, I get x equals the square root of negative 1. That's an imaginary number. I can't show that on a graph. So no asymptote. So that means that this is going to have to be this guy right here. Okay. And finally, let's check that we've done our last one here. 2x over x minus 2, x plus 2. If it's only in the denominator, it's an asymptote. So we should have an asymptote at 2 and negative 2 right there and there. And we should have a 0 at 0. Perfect. We did that one correct. Okay. Another question here. K of x. So we have to look at these ones and factor them and see which graph they are. Okay, so if I simplify this one, I would get x squared plus 2. On the bottom, I would have to factor. I need two things that multiply to be negative 2 and add to be negative 1. So I got that to be x minus 2, x plus 1. Okay, so these factors are found only in the bottom, so we should have an asymptote at 2 and negative 1. 2 and negative 1. That would be right here. So this is going to be this graph. This is K. Okay, this guy here, let's simplify. We have x minus 1. The bottom is a difference of squares. X minus 1, x plus 1. So if something is found in both the top and the bottom, it's a point of discontinuity. So I need a point of discontinuity at 1. There we go, an open circle. And then I would also need a asymptote at negative 1. Asymptote at negative 1, and I've got that right here. Okay, so this is going to be L of x. Next up, I need to simplify this guy. He got a little bit cut off. So factoring the top, two things that multiply to be positive 6 and add to be negative 5. And on my bottom, I have 3 minus x. If I factor out a negative 1, that's the same as x minus 3. Those are opposites. They're coming back to haunt us. Okay, found in both the top and the bottom, it's a point of discontinuity. So I need a point of discontinuity at 3. There we go. Discontinuous right there. Only on the top means that it's 0, so I should have a 0 at 2 right there. And this is going to be this graph. Perfect.